In the previous video, we have seen solving a network given project by PERT method. Again, one more problem I am considering in this video and explaining the process of PERT, how to calculate given things here. The first thing is given: draw the network, find the critical path, determine the expected standard duration of the completion time. Is it clear? But come back to the question that is given here. The following table indicates the details of a project. The duration in days, time duration is given in days. And here look at it, a new terminology we are finding, AMB. In this video we have seen that TO, TP, TM. Here they given AMB. Here my A refers aspiratic time TO. References we are keeping here, A equal to T0, A is T0. And M was to most likely time Tm. Is it clear? And now B refers plasmatic time duration, that is Tp. That's the only difference. Remaining everything calculations will be same, processing only will be same as we discussed last video. Now look at it. A TO is given for each activity 1 to 2, 1 to 3, 1 to 4, 2 to 4, 2 to 5, 3 to 5, 4 to 5 are the given activities. A values, that is T0 values, that is TO values 2, 3, 4, 8, 6, 2, 2 in days. TM values 4, 4, 5, 9, 8, 3, 5. TP value, that is B. TP is 5, 6, 6, 11, 12, 4, 7 is given. So we asked to draw a network. So using these activities and using this T0, TM, TP, first we need to draw a network and find the critical path. After drawing a network, of course we know how to find the critical path and determine the expected standard duration of the completion time. Now here what we are going to find it? By taking these values to the calculation tables, first we need to find the TE, expected time for each activity. Once you based on the TE, draw the network and find the critical path, which is the longest duration to complete this project, and add the critical activities, expected variances to get standard duration of completion time. Is it clear? Now let us see the calculations. So we will start proceeding for the calculation. So A, TO, M is TM, B is TP, right? So first I need to find T, expected duration for each activity 1 to 2 here. For first 1 to 2 activity, my TE I am finding. What is the formula for TE? TO plus 4TM plus TP divided by 6 here. So that is the case comes mean TO 2 plus 4 into 4 plus 5 divided by 6. This becomes TE equal to 2 plus 16, 18 plus 5, 23 divided by 6. 23 divided by 6, this becomes 3.83. 3.83. Now let me consider for activity 1 to 3. If I consider for activity 1 to 3, so my TE equal to, similarly TO is 3 plus 4 into TM, that is 4 plus 6 divided by 6. This becomes 3 plus 16, 19, 19 plus 6, 25 divided by 6. This becomes 4.17. 4.17. Similar 4.17. Similarly, I can proceed for the same calculations. TE values for 1 to 4 activity, 2 to 4 activity, 2 to 5 activity, 3 to 4 activity, 4 to 5 activity. So I will be getting from 1 to 4 activity by using the same formula 5. T is 5. Next, for 2 to 4 activity, I will be getting same as 9.17. Is it clear? After that, if I start for 3 to 4 activity, I will be getting the value as 8.33. Is it clear? Now, for 3 to 4 activity, I will be getting the TE value as 3. You get that? Now, for 4 to 5 activity, I will be getting 4.83. So, these values I can apply by using the same formula for each and every activity what is given here. Now let us find expected variance for each activity. Expected variance, I am finding sigma square equal to Tp minus T naught TO, Tp minus TO divided by 6 whole square. For each activity 1 to 2, my Tp value is 5. 5 minus TO is 2 divided by 6 whole square. This becomes 3 by 6 whole square. This becomes 1 by 2 whole square. This becomes 1 by 4. Similarly, again, for activity 1, 2, 3, I am considering for activity 1, 2, 3, my sigma square equal to TP. TP's value is what for 1, 2, 3? 6. 6 minus TO 3 divided by 6 whole square. This becomes again 3 by 6 whole square. This becomes 1 by 2 whole square. Again it will be 1 by 4 for me. Is it clear? Now for another activity 1 to 4. 1 to 4 activity, sigma square equal to TP again 6. Look at it, for 1 to 4 activity I am finding TP value is 6 minus TO value is 4 divided by 6 whole square. This becomes 2 divided by 6 whole square. This becomes 1 by 3 whole square. This will be 1 by 9. Now similarly I will proceed for the remaining calculations. I will be getting for 2 to 4 again 1 by 4, and for 2 to 5 activity I will be getting as 1, and I will be getting, and for 3 to 4 activity I will be getting 1 by 9, and similarly for last activity 4 to 5 I will be getting 25 by 36. Is it clear? Now with these calculations we have found TE values, that is expected duration. This expected duration is the time that taken to complete the activity 1 to 2. Now our intention is to draw a network diagram. To draw a network diagram, what are the things we require? Activity and time duration. The time duration we have found here TE. Using this TE and start draw this given activity. Let me draw the networks by using given activities. First 1 to 2, 1 to 3, 1 to 4. That means my starting activity for this 3 starting event for first 3 activities are 1 node. So that means my 1 is the initial node or initial event starts 1 to 2 and 3. Is it clear? And 4 also. So I can draw easily this way. Now 1 to 2 activity, time taken duration is 3.83. 1 to 3 activity, time taken duration is 4.17. And 1 to 4 activity, time taken duration is 5. Is it clear? Next activity is what? 2 to 4. That means I need to calculate 2 to 4. Time taken duration, time duration is 9.17. Is it clear? So now next activity 2 to 5. So I need to have another node, other event 5. 2 to 5. 2 to 5. 2 to 5 activity, time taken duration is 8.33. So next one is 3 to 4 activity. So 3 to 4 activity, time taken duration is 3. And last one 4 to 5 activity, time taken is 4 to 5 activity, time taken 4.83. Is it clear? So this is the required network diagram we have drawn for the given activities and with the time durations. Now we will start critical path. We will start from 1 to 2, 2 to 4, 4 to 5 one way, or else 1 to 2, 2 to 5 one way. 3.83 plus 8.83, again I need to add all the values, all the time durations I need to add. My critical path will be, what is the critical path? Again I am saying critical path is the path from event 1 to event 5 with the longest duration. So now 1 to 2, 3.83. Now I will start again and come back 2 to 4, 9.17, and I will go to 4 to 5. Is it clear? So this is my critical path here. This path only gives me the longest duration for me. So the duration is the required duration is 3.83 plus 9.17 plus 4.83 equal to 17.83 days. This is critical path and required time duration to complete the given project. And now we need to find the expected variance for the complete project. Is it clear? That becomes the sum of the critical activity variances will be gives the my expected variance for the given project. Now expected variance for the given total project here. So that becomes sigma square for complete project. You get that? This becomes critical activities you should consider. What are the critical activities? 1 to 2, 2 to 4, 4 to 5. Can you see this here? Now look at it. 1 to 2 activity, sigma square is 1 by 4 plus 2 to 4. 2 to 4 activities is 1 by 4 plus 4 to 5. 4 to 5 activities. 4 to 5 activity, look at it. 4 to 5 activities, sigma square, that expected variance is 25 by 36. So this gives on the calculations 43 divided by 36. So sigma square equal to 43 by 36. Sigma equal to square root of 43 by 36. This can be your solution. If not, for say on simplification, 1.09 will be the given solution.